Okay, exponents are used a lot in scientific notation. And so in this video, we're going to learn how to write scientific notation, or numbers into scientific notation, and how to bring them out of scientific notation. So the first thing is why do we use scientific notation? And in science, there are extremely large numbers and extremely teeny tiny numbers that require decimals and lots of zeros, and you have to count them, and to be able to read it is difficult, and so that's the reason for the scientific notation. So we're going to look at what scientific notation really means, and in this first example I have 3.8 times 10 to the third. And so that really, this is the only time that in this class you're going to see me use an X for multiplication. One of the only times. And because that's just how we do scientific notation. The dot is indeed a decimal. So what we are going to do is we're going to write it out what it says. It says 3.8 times 10 to the third. So times 10 times 10 times 10. Now, the X drives me crazy because we use X as a variable, but in scientific notation it's just used as the time sign. So if we were to multiply this out, 3.8 times 10 times 10 times 10, well, 10 times 10 would give me 100, and 100 times 10 would give me 1,000. So I have 3.8 times 1,000. So a lot of times when people are they move the decimal, and I've got 3 tens, so I need to multiply it by 1,000, so that would be 1 10, 2 tens, 3 tens, and so our answer to this would be 3,800. Another example is a small number, like 2.6 times 10 to the negative third. Now there are a couple different ways to express this. We have 2.6 times 10 to the negative third. So you could think about this as times 1/10 times 1/10, because 10 to the negative first power is equal to 1/10 times 1/10. Or you could think about it as this. I have 2.6 times 10 to the negative third. Put that over 1. My tens are not happy on the top bunk. They're going to come down. And so you can think about this as 2.6 divided by 10 to the third, or 10 times 10 times 10. So that's another way to think about it. Basically, we're dividing it, so we need to take 2.6 and we need to make it smaller by three multiples, or 10, by 10 again, and by 10 again. So if we use the little loop-de-loop method, we need to make that smaller. So a negative exponent is going to require us to divide, so it's going to be a small number. A positive exponent is going to be a large number. It's going to be larger by a power of 10. So 2.6 is a negative 3, so I need to make 2.6 smaller. So 1 divided by 10, divide by 10, divide by 10. So I would have point, fill in the loop-de-loops, of 0, so 0.0026. So let's take a look at another example. If you were to have, say, 280000, and I wanted to change that to scientific notation. If I were going to change that to scientific notation, my decimal is found at the end. I need to make this large number smaller. So I already know that it's a large number, so it has to be 10 to some positive power. And so I'm going to, there's 1, 10, 2, 3, 4, 5. So it would be times 10 to the positive 5, and this would be 2.8. We always only have one digit. You cannot have more than one and have it written in scientific notation. there. So you can only have one digit in front of the decimal point. You can have a lot of digits after the decimal point, but only one digit in front of the decimal. Or only the ones digit. So I'll do one more example. If I had 0.0004556, now you're only allowed to have one non-zero, so I should put non-zero digit in front of the decimal. If I move it, first of all, this is a very small number, so I know it's going to be 10 to the negative something. And if I move it one place, I don't have a number in front of the decimal. I don't have one place that's a non-zero, so that's 1, 2, 3. This guy's still 0. That won't work. 4. I've got one number, so I need 4. And it would be 4.56 times 10 to the negative 4th. And that is how you write scientific notation in standard form and standard form in scientific notation.